Training a single artificial intelligence model requires a massive, constant flow of electricity. To keep these server farms online 24/7, the tech industry is racing to build out next-generation battery storage at a scale never seen before. But the physical materials required for those batteries originate here, in the cracked earth of the high Andes. The trajectory of this demand is vertical. By 2040, the global appetite for lithium is projected to quintuple, fueled by the rapid expansion of AI data centers and the transition to electric vehicles. More than 50% of the world's known lithium reserves are concentrated in this specific geographic bottleneck, where the borders of Argentina, Bolivia, and Chile meet to form the lithium triangle. The entire global tech transition relies on the stability of this one region. If production stalls here, the digital and green economies lose their primary engine. Lithium mining in the triangle is an industrial-scale plumbing operation. Miners pump millions of gallons of mineral-rich groundwater to the surface, collecting it in these brilliant green pools where the Andean sun evaporates the water. The environmental math is brutal. For every ton of lithium produced, operators must extract 15 times more water from the earth than the local rainfall can naturally replace. To manage this vanishing resource, the three nations of the Triangle have adopted radically different political strategies, each creating its own unique pressure point in the global supply chain. The stability of the energy transition now rests on the volatile collision between these political experiments and the physical limits of the desert. In 2009, the Bolivian government nationalized its entire lithium industry. Every stage of the value chain, from extraction to processing, was placed under the control of a single state corporation. This policy of total state control stalled production for over a decade. Without international investment or domestic technical expertise, Bolivia has failed to generate any significant global supply, despite sitting on the largest reserves on the planet. Now, in an attempt to catch up, the government is bypassing environmental impact studies and ignoring laws that require consultation with indigenous communities. These new fast-tracked contracts are being quietly signed with state-backed corporations from Russia and China, further distancing the region from Western markets. By attempting to fiercely protect its natural wealth, Bolivia effectively paralyzed its own development and locked the world's largest lithium store behind a massive wall of bureaucratic failure. Argentina takes the opposite approach. Its constitution delegates all mining rights to individual provinces, leading to a decentralized and unregulated race for investment. This chart shows the result of that open market policy. Billions of dollars in foreign capital are pouring in, with over $2.4 billion dedicated to construction and nearly $3 billion to feasibility studies for new extraction sites. That industrial surge is a direct threat to the indigenous Kola people. They rely on the same scarce groundwater that the mines are now pumping at commercial scale. To protect these investments, local provincial governments recently altered their own constitutions, making it easier to waive indigenous land rights and limit the ability of communities to protest. These legal changes sparked immediate resistance. Protesters carrying rainbow Wipala flags blocked major roadways and violently clashed with heavily armed authorities, creating intense operational risk for the very companies the government hoped to attract. Argentina's free market boom has created a cycle of social instability, making its portion of the supply chain increasingly unpredictable for global tech firms. Chile utilizes a hybrid model. The state retains ownership of the lithium, but leases extraction rights to private global conglomerates in exchange for high royalties. This system has made Chile a high-volume leader in the market. Its massive evaporation infrastructure currently provides the consistent flow of lithium required to feed the global battery industry. But the cost of this efficiency is the rapid desertification of the Atacama ecosystem. Aggressive brine pumping is pulling moisture from the soil and destroying the small-scale agriculture that once thrived here. The ecological collapse is already visible. In the areas most affected by mining, native flamingo populations have dropped by 10 to 12% as their water sources disappear. Chile demonstrates that while high-volume extraction is profitable, the current method of environmental depletion is fundamentally unsustainable for the region's long-term survival. Time is running out. Global energy agencies warn that by 2035, the world will face a 60% deficit in the lithium supply needed to meet its climate and technology goals. That massive supply gap is forcing companies to double down on destructive evaporation methods rather than pausing to develop safer alternatives. This chart compares water use across mining technologies. Solar evaporation shows massive atmospheric water loss. Direct lithium extraction avoids this, but isn't water-free. The in-process row reveals DLE still requires significant water, with impact depending on the power source. The future of modern technology is held hostage by more than just local politics. It is limited by the physical boundaries of the Earth itself, demanding a complete rethink of how we power human progress.